Okay, so this lesson is actually going to combine two sections in your textbook, 7.4 and 7.5. We're going to start with 7.4. That's the front side of the page. 7.5 is the back side. So starting with the very first thing, a midpoint. And by the way, the lesson here is not so much on calculating angles, but helping you find sides, okay, of polygons. So the midpoint is just as it indicates. The midpoint of a line segment would create two equal parts. So if you have some line, A and B, okay, if its length is, say, 10 centimeters, at 5 centimeters in the midpoint, okay, you would create two equal sides. Okay, so that's all that that's telling you. A mid-segment would be if you were to imagine a line, okay, let's say line AB, and if I were to find the midpoint of AB, let's say somewhere there, and then let's say I have another line, BC, and the midpoint of that line, let's say, is there. Let's finish this polygon, so we have something like that. So we have a midpoint on that two lines, AB, on that line, midpoint between BC. This line joining the two midpoints is called the mid-segment. So this right here is your mid-segment. So some things that are important about a mid-segment. First of all, we just said that these two are going to be equal. These two are going to be equal. The mid-segment line, as indicated here, is going to be parallel to the third side, this being the third side. So these two are going to be parallel. That's one thing to note. And the other thing to note is the mid-segment is half as long as the third side. So if I were to add, let's say, point X there and point Y, okay, the length of XY is half the length of AC. All right, and the other thing to note about a mid-segment that will help you answer the questions coming up is this third point here illustrated with the diagram. This mid-segment here, okay, is going to create two triangles, one small and then one the original, so that the height of the smaller triangle, so if you look at the diagram, line A, that's going to be half the height of the larger original triangle. So line A is half of line B. So if B is 10 centimeters, then A is going to be 5. All right, the next term I want you to focus on is the median. If we have points A, B, C in our original triangle, if you draw a line from the vertex to the midpoint of line BC so that you have equal sides here, the line here, line AX, is your median. Okay? So what the median does in the diagram above is that it cuts the area in half. So bisect in this situation means that it's going to cut by half. So according to the diagram above, let me just move that over. According to the diagram above, the area, okay, of triangle ABX is going to equal the area of triangle AXC, okay? So that each triangle is half the area of the original larger one. If you would put them together, it would be the whole. And the final point here about the centroid is that if you had, let's say, some triangle again, A, B, C, and I were to draw the median from all vertices, so from A to there, so that those two are equal, okay? From B to there, so that those are equal, and then from C to there, so that these are equal. This point here, okay, is my centroid. Okay, looking at example number 1, we are told that the line DE bisects AD. So right there, bisect means cuts in half. If it's cutting AB in half, and we're told that this is 4 centimeters, and this is the midpoint, okay, mid-segment, because it's joining on the other side, mid-segment, then this line here must also be 4 centimeters, BD. So for part A, the length of DE, which would be this line here, remember is going to be half of the 10, according to the mid-segment rule that we talked about earlier, right? Because you have this midpoint connecting this midpoint, therefore these two lines parallel, that's going to be half of that third line that we talked about. So in this case, DE is going to equal 10 centimeters divided into, so it's going to be 5 centimeters. And then the length of AB, well, earlier we found out that DB was 4 centimeters, so AB is going to be 4 centimeters times 2, so AB will be 8 centimeters. Okay, for example number 2 on the back, we have to remember some things from other units. So just taking a look at this question, given that AE is a median of triangle ABC, find the area of triangle AEC. So the fact that this AE is a median tells us that the area of the triangle AEC is half the total area, right? So if we were to find the area of triangle ABC, the original large triangle, then cutting it in half, we would have the area of AEC. And if you remember, to find the area, we need to have or recall the equation. Area of the triangle is half the base times the height, okay? In other words, B times H over 2. Well, to do that, we would have to know the sides. And so for now, we know that this is 3 meters, and we know that this is 5 meters. But we are not given this side. If you recall, because it is a right angle triangle, we can use the Pythagorean theorem. Okay, if you remember, that was a squared plus b squared equals c squared. And we can treat that as side A, that's side B, and that's side C. So plugging everything in, okay, we would have 3 squared plus b squared, which we don't know, is equal to 5 squared. That would give me 9 plus b squared is equal to 25. So b squared is equal to 16, which means that b is the root of 16. So b is equal to 4 centimeters. Okay, now that you know that b is equal to 4 centimeters, we can find the total area of the original triangle. And so that would be 4 times 3 divided by 2, right? So the base, which is the 4, times the height, which we know is 3, but half, which is why we're dividing it, and that turns out to be 6 centimeters squared. Okay? Now that's the original triangle, but because we want the triangle for AEC, or area of AEC, that's going to equal 3 centimeters squared. Okay, and the rest of this page is pretty much all of 7.5, and it's related to 7.4 quite closely, so that's why we're looking at them together, which basically says that when you are looking at a quadrilateral, which is the diagram right over here, and if you were to find the midpoint of any of the sides, so let's say the midpoint of that side, the midpoint of this side, the midpoint of this side, and the midpoint of this side, if those are in fact midpoints, we would have the following, right? Okay, and then once you were to join these midpoints, so I'm going to try to do that as best as I can. Okay, the shape that you produce as a result of joining those midpoints would also be a parallelogram, which means that the opposite sides are going to be parallel to each other. Okay, and that's going to help us determine angles if we were to be given some angles of what's happening in this shape here. And then the other thing here to note is what happens when you look at diagonals of a quadrilateral. Remember, diagonals are when you join the vertex of one end to the other. So if I were to take this diagonal, and I were to take this diagonal, okay, they would bisect. What does that mean again? Cut in half, which would mean that this is equal to this, and this is equal to this. Okay? Okay, so let's look at the example here. The first example, we're given this quadrilateral, and we are told that the line RU has a length of 3.6 centimeters, and we are told that RT has a length of 6 centimeters. So what is the length of SR? Okay, something just happened with my pen. So SR would have to be the same as RU, right? Based on the bisect rule we just looked at above. So SR would have to be 3.6 centimeters. The line SU, something has gone wrong. Let me pause. Okay, let's try this again. The line SU, well, we know that this is 3.6, okay? So SU would have to be 2 times that 3.6, right? Which gives us 7.2 centimeters. See the line VR. So VR, this is a bisect, so that would have to be the same as the RT. So VR is equal to 6 centimeters. And then finally, D, the line V and T, VT, would just be 2 times your 6, right? So that's going to be 12 centimeters. Okay? To do the very last one, I want you to try that one on your own. And here you need to refer back to maybe your cue cards to figure out the rule that you're using, the PLT rule. And we will take that up tomorrow in class. I tried to keep this under 15 minutes. and I just about did. See you tomorrow.